Hello and welcome to my second lesson on a series of lessons on the topic further logarithms. In this particular lesson, we're going to turn our focus to the laws of logarithms, and so let's head there. Now, we're going to focus our attention first of all on some laws that will be necessary for us to simplify some expressions. And so before us, we have some laws. We have log of x times y to base a. That one equals to logarithm of x to base a plus logarithm of 8 to base a. That means if the sign between x and y is a multiplication, we can split them and put an addition as we have written here. So that we have log of x to base a plus log of 8y to base a. Similarly, log of x of y to base a is the same as we have the log of x to base a minus log of y to base a. Because we have division here, we therefore would have subtraction. Whenever we have multiplication, we have addition there. Again, log of x raised to power n to base a normally is written as n, then everything else. Log of x to base a. If we were having log of a to base a, that is log of a number to the same base, the answer would be 1. And lastly, log of 1 to base a, the answer should always be 0. And so these ones are going to be helpful for us as we try out some questions which have to deal with the laws of logarithms. Let me give a disclaimer or a caution here. When we have log of x to base a times log of y to base a, the sign between them, the two of them being multiplication, not addition, or when we have the expression log of x to base a divided by log of y to base a, the sign between the two terms being a division, not subtraction, these two expressions cannot be simplified further. They are the simplest they can be. They cannot be simplified further past what we have there. Similarly, the expression log of a means log of a to base 10. That is when the base is not specified, then it's assumed to be base 10. The same way when you don't have a sign next to a number, we assume the number is positive. With that, let's attempt some questions. And so we are told simplify the following. We have log of 3 plus log of 4. According to the first law here, we have log of x plus log of y. The base is the same. It means just log of 3 times 4, which is log of 12. And that's simple. If we have log of 30 minus log of 3, it means log of 30 divided by 3, which is log of 10. Since the base is not specified, we assume it is log of 10 to base 10, which is, as we've said here, log of a number at the same base is 1. Therefore, the answer is 1. If we have half log of 4 minus log of 6, it means, according to this third law here, we have log of 4 raised to power half minus log of 6. 4 raised to power half means a fractional index of 4. The index is 1 over 2, meaning the second root, which is square root of 4. No wonder I've written root 4 there. And therefore, this is going to be log of 2 divided by 6, which is log of third. Now, if we have log of 16 to base 2 minus log of 8 to base 2, it's going to be log of 16 divided by 8, which is log of 2 to base 2, which is, again, 1, because log of a number at the same base is 1. Turning on to more examples. If we have this expression here, we're going to simplify it as follows here. The 5 is going to be raised to power 2, which is now log of 5 squared over to base a, sorry. The log of 4 to base a will remain as it is. This other one here is going to be log of 10 squared, like this, to base a, which is, if we put in the same bracket, we're going to have 5 squared times 4 divided by 10 squared, which is 100, which is 25 times 4 over 100, which is log of 1 to base a, which is 0, according to one of the laws we just talked about. Again, if we have log of 3 to base 9 plus log of 27 to base 9, again we have log of 3 times 27, all of it to base 9, which is log of 81. Notice that 81 is a power of 9, which is 9 squared. Therefore, we have log of 9 squared to base 9, which is 2 log of 9 to base 9, which is 2 times 1, which is 2, and that is the answer. Now, moving on to another question, we have this number here. So again, we're going to write this one as log of 2 base 8 of 72 divided by 9 over 8. Therefore, it is log of 8 squared, which is 2 log of 8 to base 8, which is 2 times 1, which is 2. That's the answer there. Now, another question. We are told if log of 2 is that one there and log of 3 is that one, simplify. Log of 12, log of 1.08. Now, we are going to have to express the 12 and 1.08 in terms of powers of 2 and 3 in some way. And that's the hint there. We express the 12 and 108 or 1.08 in terms of powers of 2, 3, and or 10 in some way. 10, remember, is a common power. Say, you see, we know the powers of 10, like 10 squared, 10 raised to power 3, less 10 raised to power 6 is a million, 10 raised to power 7 is 10 million, whatever. We know the powers of 10. So 10 doesn't feature here, but since 1.08 can be written in terms of powers of 2, 3, and 10, the question will still be doable without being given the logarithms of power of the logarithms to base 10 of 10. And therefore, this is what we're going to do. In the solution, the logarithm of 12, we're going first of all to write 12 is the same as 2 squared times 3. That means log of 12 is the same as log of, in brackets, 2 squared times 3, which is open the brackets using the one of the laws we just talked about. And there we're going to have a 2 log 2 plus log 3. And we know log 2 is 0.3010 and log of 3 is 0.4771. Therefore, the answer is going to be 2 times 0.3010 plus 0.4771. And therefore, the answer is 1.0791. And that is the answer. The last question we were given 1.08. 1.08 can be written as 2 squared times 3 cubed over 10 squared. And therefore, logarithm of 1.08 is the same as logarithm of what we have here after the equal sign. Using the first and second laws we talked about, and also other laws we talked about there, it can be written this particular way. The 2 will come down here, the 3 will come down here, and these 2 again will come down here. Therefore, we're going to have it this particular way. We know that the power log of 10 to base 10 is 1. Again, that's one of the laws we also talked about. And therefore, we're just going to have to simplify this expression here, which is going to be 0.0333. And therefore, that is the answer. And that brings me to the end of the second lesson on the topic of further logarithms. Please check out for more as we want to simplify or make the concept of further logarithms even better or easier. Thank you.